Every single day, we're just bombarded with studies, right? Studies claiming to know how we think, how we vote, how we live our lives. But how do we sort through all that noise? How do we tell what's real and what's not? Well, today, we're going to decode the secret language of social science. These are the core ideas researchers use to make sense of our incredibly complex world. So, let's dive in.
Think about it. We see claims and studies about human behavior literally everywhere. On the news, on social media, you name it. But how do we actually know what to trust? How can you or I tell a really solid piece of research from, just some speculation somebody cooked up? To do that, you've got to know the basic rules of the game.
So, here's the plan. Think of this as our little research journey together. First, we'll cover the big question. What even is social science? Then, we'll see how big ideas meet the real world. We're going to explore the huge difference between studying big groups versus just one person, and why science speaks in probabilities, not certainties. And then, and this is the big one, we'll hit the single most important rule in all of science. And finally, we'll wrap it all up by looking at why any of this really matters to you.
All right, first things first. What are we actually talking about here? Put really simply, social science is just a structured, systematic way of building and testing our ideas about how the human world works. It's really a quest to move past our gut feelings and intuitions and find knowledge that's reliable because it's backed by evidence. So where does any research actually begin? Well, it all starts with this really fundamental tension, right? It's the tension between the ideas we have in our heads about how the world works and the messy, complicated world that's actually out there. And this really shows you the two halves of research. On one side, you've got the theoretical. You can think of this as the map we draw. It's made up of our ideas and our hypotheses. And on the other side, you've got the empirical. That's the territory, the real world that we can actually go out and observe and measure. And, the best research is really just a constant conversation between these two, always checking our map against the actual territory to see if it holds up.
Okay, so once a researcher decides they want to go explore that territory, they have to make a pretty big choice. Are they trying to understand one person's completely unique individual story? Or are they trying to map out the big highways that lots and lots of people travel down?
And this brings us to a really important kind of fancy word, nomothetic. It comes from the Greek word nomos, which means law. And honestly, most social science you'll read about is nomothetic. It's not trying to explain why your cousin Bob did that one weird thing. Instead, it's trying to find general patterns, or you might say laws of behavior that apply to many, many people. And when you look at them side by side, the difference in these approaches is huge. The nomothetic path, its goal is to find those general laws, and it usually uses big data sets, experiments, things that are quantitative, numerical. But the ideographic path is totally different. Its goal is to understand one unique person or situation, and it uses qualitative methods like in-depth case studies or long interviews. Now, both of these are super valuable, but when you hear people talking about a new study, they are almost always talking about nomothetic research.
So the researchers do all this work. What do they actually find at the end of the road? Well, one thing's for sure. It's not absolute, undeniable, capital T truth. The kinds of conclusions we get from social science have a really specific character.
First off, they are probabilistic. In a world as complex as ours, with billions of people, we almost never get 100% certainty about anything. It's just not possible. So instead, research tells us what is likely to be true, or what's probable. And that's exactly why statistics are so important. They're basically the language of probability, helping us figure out the odds that what we found is a real pattern and not just some random fluke.
And second, the big picture goal, the driving ambition, is often causal. Now, not every study tries to prove cause and effect. Some just describe things. But the ultimate prize, that's understanding what causes what. Because let's be real, if you know what causes a problem, well then you've got a shot at actually fixing it. That deep down desire to understand why is what really pushes science forward. Okay, deep breath. We have now arrived at the most important stop on our entire journey. I'm serious. This is the one rule, the one idea that truly separates real science from everything else. Think of it as the ultimate guardrail that keeps research honest and prevents it from driving off a cliff.
This incredible idea comes from a philosopher named Karl Popper, and what he realized was kind of mind-bending. He said that a truly scientific claim isn't one that can be proven true. It's one that could, at least in theory, be proven false. You have to be willing to say, right from the start, here is the evidence that would make me throw my entire theory in the trash.
And here is the classic example to make this crystal clear. When Albert Einstein came up with his theory of relativity, he made an incredibly risky and testable prediction. He said, during a solar eclipse, we should be able to see that the sun's gravity bends the light from distant stars. If we looked and the light wasn't bent, his whole theory was wrong. It was falsifiable. Now compare that to some of Sigmund Freud's early psychological theories, which were so flexible they could explain a patient's behavior and also the exact opposite behavior with the same theory. There was just no way to ever prove them wrong, which ironically means they weren't really scientific.
And listen, this isn't just some dusty old philosophy debate. We see unfalsifiable claims popping up all over the place today. Let's take a look at a really common one.
So take the claim that there are secret microchips in vaccines. Why is this a perfect example of an unfalsifiable claim? Because no matter what test you try, there's always a ready-made excuse. If you look under the world's most powerful microscope and see nothing, the response is, well, of course, the chip is too small to be seen. If you use a scanner and find no signal, they say, oh, that scanner you used was flawed. Or the technology is just too advanced for you to detect. See, there is no piece of evidence you could possibly present that would disprove the claim. It's a closed loop, and you're just left going in circles forever.
So here we are. We've made it to the summit of our journey. We've learned a bunch of big words today, right? Theoretical, empirical, nomothetic, probabilistic, causal, and the big one, falsifiable. But I really want you to see that these aren't just words for an exam. They are the practical, hands-on tools we use to build and evaluate knowledge about our world.
And this is how all those different pieces click together to build a really strong scientific theory. First, it has to be coherent. It needs to make logical sense and not contradict itself. It's usually causal, meaning it tries to explain why things are the way they are. And most importantly, it generates hypotheses that are testable, which means by definition, they are also falsifiable. A good theory sticks its neck out and makes risky predictions that we can actually go out and check against reality.
So the next time you're scrolling and you see a headline about some brand new study, you now have the tools to ask the right questions. You can ask, is this actually based on evidence? Is it trying to find a general pattern? And most of all, does it make claims that could actually be tested and proven wrong? You now know the rules of the game. So the real question is, how will that change the way you see the world?